Okay, dear colleagues, morning for everybody once again, because we started to record this session, plenary meeting 1 for the first day, and again to remind that everything is available on Facebook simultaneously. In the beginning, I want to shortly introduce Lithuania, or just for 4 minutes. It's obviously a pity that it's not possible to be together with you in Šiauliai, in Lithuania, in this very nice summer day. Currently, we have 27 degrees according Celsius. It's quite hot. Let's say in the morning, approaching to 10 a.m. and it's really hot. And it is expected to have a higher temperature today. Again, let's hope that everything will be all right without any technical problems. Let me share one Do you hear sound?
Yes.
Yes, we hear.
Good. Okay, I hope that despite some maybe technical issues, it was possible to see this short video about Lithuania. No answers from colleagues? Okay, at least somebody was able to observe. Okay, if you have some questions, according to our program, we will start in few minutes. First plenary presentation. Do we have Paul from Malta? I can see right now. Okay, still I did not see our colleague Paul. I think he joined us because he sent a presentation. Hello, Dagnia. Hello, Paolo. Please connect your microphone if you want to say something.
Good morning, Vincentas. Good morning, everyone.
Morning. Hello, Boris. Morning, Boris.
Hello.
Morning, Metka.
Good morning.
Hello, both of you.
We are waiting Paul, but it's not. He is not currently connected. I don't know why.
No.
PAOLO.
Yes, Vincentas.
I think it would be a good idea to replace Paul with you.
That's okay for me.
Because maybe some misunderstanding with time or something else, because he sent the presentation to me this morning. Everything is all right. However, I do not see him here. I think it's no problem to replace, and you can start first. And second, it can be Paul, right?
That's okay. There is no problem for me.
Hello, Vladimir.
Hello? So, Vincentas, do I begin now?
Yeah, please start your presentation. And I want to announce that we decided to replace, not in order to keep our time frame, we decided to reverse. First Paolo and second maybe Paul. Okay, Paolo, you can start, share your screen, and you have 45 minutes. It means half hour presentation and 15 minutes for questions and discussion. And I kindly suggest colleagues, maybe during your Paolo presentation, you can raise some questions, you can write in chat window, or after that, you can raise your hand in order to ask. Okay.
That's good. First of all, I wish to thank you, Vincentas, for having invited me to participate in the Baltic Symposium. Secondly, I want to apologize for my English because I don't speak English from many years, and I am speaking only Italian from 3 or 4 years. Therefore, I have fears that my English is not good enough for your level. However, I hope it is. I hope it is, but I am not sure that it is.
Don't worry, Paolo, please use international English.
Okay, yes, of course. I will use international English since it is the only one I know. Therefore, for sure. So, now some brief words on my presentation. My presentation concerns the possible role of history of science, of history of mathematics in particular, within mathematics education. Of course, this is a huge subject. It's a subject on which in the last years there has been written many papers and books, and is a subject on which several scholars have different opinions. I will take a specific example, that is the example of the integral calculus. This means that my presentation concerns mathematics education at the secondary school, possible in the last years of the secondary schools. This is the subject. How can history of mathematics help mathematics education? This is the subject. My presentation will be divided into 3 main sections. The first section will concern the general relationships between history of mathematics and mathematics education. The second section, with which the specific argument of the integral calculus begins, concerns the way in which Archimedes dealt with some problems concerning years and volumes of curvilinear figures. And of course, the aim is to show that the method used by Archimedes can be of help to introduce the integral calculus. The third section, which is far briefer than the second one, regards instead the way in which Newton introduced the concept of integral, of definite integral, in practice in an almost modern way. Finally, there will be slides in which I summarize what I told during my presentation and in which I draw some very brief conclusions. Therefore, this will be the itinerary I am trying to describe. Now, the most difficult moment, that is to try to share the slides. Okay.
Don't worry, Paolo, it's continuous learning. Learning by doing.
Exactly. Allora.
Okay.
Okay. Are you seeing?
Yeah.
Good. Okay. On the left, you can see Archimedes. On the right, you can see Newton. This is... Now, are you able to see the slides, History of Mathematics and Mathematics Education? Okay,
Yes.
good. So, of course, as I have told, my idea is to show that history of mathematics can be of help in the introducing some elements of mathematics education. This is the basic idea. Of course, first of all, it's necessary to justify this idea. Why it why can history of mathematics be useful in mathematics education? And I think it's possible to individuate 3 items for this answer. The first is that starting from history, it's possible that the pupils, the learners, guess the conceptual origins of some mathematical notions and concepts. In this way, they can realize that this concept has been created to solve some concrete, some specific mathematical problems. Why do I say this? Because there is the tendency, and this tendency is completely comprehensible from a certain point of view, there is the tendency to offer a formalized approach to the concept and afterwards to see the application through which this concept can be used to solve the problems. While, in my opinion, it's important that the students understand that the formalization of the concept was a successive step when the numbers and the width of the problems increased and the necessity of precise definition became necessary. But at the beginning, when the concept was when we are speaking of the genesis of the concept, is important to understand that the mathematical concepts are introduced to solve specific problem. How? Because what is the question when the teaching begins in the formal approach, in my opinion? That if the teaching begins with the formal apparatus, there is, in fact, the risk that the pupils do not guess its scope and utility and mistake the real meaning of the formalization and of the concept introduced. It seems that mathematics belong to an absolutely abstract realm, whereas there are also concrete problems which have to be solved. Secondly, this is the first scope, that is to say, to understand the genesis of the mathematical concept and to guess that, in a sense, this origin is connected to some, so to say, practical aspect of mathematics. This is the first step, the first issue. Second issue, a historical approach can be useful for the students to realize not only the technical aspect of mathematics, but also the human aspect. Mathematics exists because of the hard work of the mathematicians. It's a human activity in which, before reaching the final presentation of a given concept or the general solution of a given problem, there is a long history of failures, attempts, and improvement. This history has been needed to reach the final definition and the final utilization of a concept. And this history is very instructive, not only from a mathematical, but also from a human standpoint. Mathematical, Therefore, if appropriately presented, is neither sterile nor mechanic. Thought obviously, this is simply obvious. Several technicalities have to be learned and are absolutely necessary. Finally, and even more general questions. Nowadays, interdisciplinarity is a commonplace. But to conceive and to develop an interdisciplinary education is not easy. Under the respect as well, history of mathematics can be of help. We will speak, as I have already told, basically of Archimedes and in part of Newton and of the birth of integral calculus. Therefore, only restricting to the subjects I will deal with, it's possible to conceive an educational itinerary in which the teachers of history, physics, mathematics, and philosophy or history of philosophy, where this discipline is taught, collaborate. Therefore, history of mathematics can also be useful to conceive an interdisciplinary educative itinerary. So, now let us come to the problems which I will deal this morning. That is the areas of the curvilinear figures. Why is it important to deal with this problem? Because today the integral calculus and the concept of definite integral are used to find such an area and such a volumes. However, that is the areas and the volumes of curvilinear or mistilinear figures. However, before the introduction of this notion, a panorama on the way in which such problems was addressed in the history of mathematics can be a very useful educational means. Why? Because this might help the learners to fully understand the difficulty of the problem, and they might also understand some techniques that were used before the introduction of the integral calculus, and to see that in these techniques there are some elements, some ingredients which foresee, which are anticipations, so to say, those I am fully aware that the term anticipation is not very good to be used in history. However, let us speak from an intuitive point of view. It's possible to see that in these old techniques, there are some anticipation of the concept of integral calculus, but that there are still differences between these old techniques and the integral calculus. Therefore, a comparison between such a technique, such a method, and the integral calculus can be of help for the learners to reason about mathematics. In particular, the learners can guess the relationship between curvilinear and rectilinear figures, to understand the link between the concept of infinity and the ad absurdum reasoning, and third, to enter the problem of the rigor and generality in mathematics. Of course, when we speak of such a general and huge problem as the calculation of areas and volume of curvilinear figures, many authors might be chosen as anticipators of the integral calculus, or even as the inventors of the integral calculus. I name only 4 of the most important: Johannes Kepler, Bonaventura Cavalieri, Evangelista Torricelli, Gottfried Wilhelm Leibniz. That's obvious. There are several possible didactic itineraries, not only educational itineraries, not only one. For my presentation, however, I have chosen a proof by Archimedes and some insight by Newton, where the concept of integral, I am referring to Newton, is introduced in almost modern terms. With regard to Archimedes, it's to point out that Archimedes' procedures are extremely interesting because they seem an anticipation of the integral calculus, at least from a conceptual, and I will specify what I mean while using the word conceptual, at least from a conceptual, if not from an operative standpoint. Archimedes invented two methods correlated to the calculations of the curvilinear surfaces and volumes, the methods of the barycenters and the method of exhaustion. I will focus only on the method of exhaustion. It's to remark that such a method was used also before Archimedes. For example, if you read the last books of Euclid Elements, you find that Euclid used the exhaustion method, but Archimedes was the true master of this method, was the man who brought this method to the highest level. First of all, of course, it's necessary to explain what the exhaustion method is. And from the point of view of the invention, is to point out that the method of exhaustion or exhaustion method, both the expressions are correct, was invented before Euclid and obviously before Archimedes by Eudoxus of Cnidus, who lived in the first half of the 4th century before Christ. The method works like this. This is the scheme, the procedural scheme of the method. You want to prove that two quantities, A and B, be they areas or volume of two figures. You want to prove that two quantities A and B are equal. Suppose they are not equal, and suppose that A is bigger than B. You construct a series of figures which approximate the figure A by defect, and among them you find one whose difference from A is less than the supposed difference between A and B, that is, the difference A minus B. Then you are able to prove that this figure should be at the same time greater and less than B, which is absurd. Therefore, this hypothesis that A is bigger than B has to be removed. Afterwards, you suppose A to be less than B, and in a similar manner, you reach a contradiction. Therefore, since A can be neither bigger nor less than B, you reach the conclusion that A has to be equal to B. This is the general scheme. Now, of course, as always in mathematics, it's appropriate, and I am now proposing a demonstration which can be repeated in classroom without any problem. It's a relatively easy demonstration. Of course, I was saying it's necessary to propose an example to show how this method works.
Paolo, 1 minute, 5 minutes left. You
Yes.
are 5 minutes left.
Yeah, how many, Vincentas?
Five.
Okay. Okay. I have 5 minutes. No, excuse me, Vicenta, I have misunderstood. I can speak only still 5 minutes.
Yes, 5 minutes left. Just continue.
Oh, excuse me, but I thought I have 45 minutes.
30, half an hour for presentation and 15 minutes for discussion. We will have discussions later on.
Okay, I had misunderstood. I thought 45 minutes to speak.
30 minutes for presentation, 15 for questions and discussion.
Okay, oh my God. Okay, okay.
Continue.
Okay, I apologize. Okay. The exhaustion methods. The pupils know that given a circle whose radius is r, its surface is pi grec r square. However, if you ask them to prove this statement thought in an intuitive manner, probably no one will answer the question, because the question is not easy. Let us see how Archimedes solved the problem. So, Vincentas, I will present this demonstration and after that stop. Okay, each circle, Archimedes proved that each circle has the same surface as the right triangle A, of which a leg, a catetus, is equal to the radius, and the other leg is equal to the circumference. Let us see how he proceeded. The proof is conceived through the exhaustion method. Suppose that the circle ABCD to have an area S, let us call this area S, greater than A. It's possible to inscribe the square ABCD of area Q in the circle. Suppose that Q is less than A. It's possible to bisect the 4 arcs of circumference AB, DC, CB, BA. B, F, and M, 2 of such points of bisection. Let us construct the regular octagon FA, MAN, MD, and so on, whose area is we call O. Suppose that O is greater than A. O is greater than N. If you suppose that O is less than N, it's possible to continue bisecting the arcs of the circumference until reaching a polygon of 2 elevated at the end sides, whose area is greater than A but less than S. From the center O of the circle, draw the perpendicular NO, this perpendicular, to the side AF, this is the side, of the octagon. Such a segment is less than the altitude of the triangle, which is equal to the radio. On the other hand, the octagon perimeter is less than the rectified circumference. Therefore, the octagon area is less than A. But this is absurd, because we have supposed O to be greater than A. Therefore, the area of the circle cannot be greater than that of the triangle. To a similar reason, it's possible to prove that the area of the circle cannot be less than that of the triangle. This means that the area of the circle and that of the triangle are equal. Of course, I have finished and I stop here and I say...
Paolo, sorry, you can continue. We mixed a little bit. You can continue, 45 minutes, okay.
Okay. Thank you, Vincentas. So still 15 minutes.
Yes.
Okay. So let us see the basis of the reasoning. The reasoning of interest behind this proof are numerous. First of all, let us see the axiomatic basis of the reasoning. The axiomatic basis of the reasoning is the following one. If a continuous magnitude is greater than another one, a magnitude greater than the smaller and smaller than the greater one exists. Hence, if you suppose the octagon to have a surface less than the triangle A regular polygon of two elevated at the end sides exists, whose area is less than that of the circle but greater than that of the triangle, whose supposed area, of course. It is thus possible to apply the method to such a polygon. Therefore, something like the principle of continuity is one of the axiomatic bases of the reasoning. Second, in the proof there is a critical point. Archimedes seems to give for granted that the perimeter of the polygon inscribed in the circumference is smaller than the circumference itself. As a matter of fact, Archimedes does not give this for granted because in another work on the sphere and cylinder, he clearly wrote as a postulate, the shortest among the lines having the same extreme is the straight lines. Therefore, this granted, it's obvious that the perimeter of any polygon, of any regular polygon inscribed in the circumference is less than the circumference. Third question, there is a further possible problem. It might happen, and this is a very subtle problem, it might happen that the difference between the area of the circle and that of the inscribed polygons diminishes, but without tending to zero. Archimedes also considered this problem on the sphere and cylinder and proved that it is not the case. That is, it happens that the difference between the area of the circle and the area of the regular inscribed polygons of the circumference tends to zero. Therefore, it's clear, a very important question, that in this method, the fundamental concept of differential calculus and of integral calculus is involved. And what is this concept? It's the concept of limit. Therefore, this proof can be shown to see how the concept of limit is born, how this so important concept was introduced in mathematics. It was introduced to solve some specific problem, like the calculations of curvilinear areas. Therefore, it's not introduced in a formal way. Archimedes does not define what a limit is, but as a matter of fact, he uses this concept. Of course, the further questions is the question, what are the relations between the exhaustion method and the integral calculus? Okay, now, since the time is not much, I summarize. Of course, the most important similarity is that Archimedes considered a sum of infinite areas, and the sum of infinite areas is given by the sum of the areas of the circular segments AA, AB, BC, CD, DA, DF, and so on. These infinite areas whose sums tend to null. whose sum tend to null, because the difference between the inscribed regular polygon and the area of the circle tends to null. In other terms, he uses the concept of limit and the sum of infinitesimal areas, and the concept of limit and the sum of infinitesimal areas is used also in the integral calculus. Of course, what are the differences? The differences conspicuous are manifest in the sense that in Archimedes, the searched area is not obtained as sum of infinitesimal areas. No, this concept is used only to develop an ad absurdum reasoning. An ad absurdum reasoning, the ad absurdum reasoning which we have seen. Whereas in the integral calculus, a technique is supplied to calculate the sum of infinitesimal areas. Therefore, this is an evident difference. What does difference show? This difference shows that in Archimedes' epoch, or better, Archimedes had the idea of limit. He had cleared the concept of limit, and in my opinion, it's extremely instructive to expound, to explain to the students how the concept of limit is born. On the other hand, what was lacking in Archimedes is a technique of calculations of the limits, whereas the inventors of the infinitesimal calculus in the 17th century progressively created a technique to calculate the limit. Of course, since this technique was lacking, also the possibility to calculate the sum of infinitesimal area was lacking. Therefore, what does this mean? That the basic concept, that of limit, is the same. That the idea to use infinitesimal area is present in Archimedes, but the lack of a technique and the lack of a general view on the problem prevented Archimedes to invent a calculus as the integral calculus. Therefore, once we have clarified these aspects, it becomes clear that it's extremely educative for the students to understand that the concepts are introduced to solve single problems. In this case, the concept of limit and the concept of infinitesimal areas. Afterwards, when the problem became more difficult, more complicated, so to say, not to calculate only the area of a circle or of some regular figure, but they are subtended to the graphic of any function, it's clear that a method as that of Archimedes is not anymore working. Therefore, a progress is necessary. Now, it became necessary to introduce in abstract terms the concept of limit and the concept of integral. But after having understood this historical itinerary and this itinerary tied to concrete problems, it becomes easier for the student to accept a formalization which otherwise might appear a little bit too abstract. This is the main point, in my opinion, that an historical approach might help to guess the genesis of the concept and their historical basis. Well, I don't consider this, and I want to conclude my speech speaking of the way in which the concept of integral was introduced in almost modern term. Why I speak of almost modern term? Because as a matter of fact, the modern term, the concept of limit and of integral using the epsilon delta method was introduced only in the 1820s. However, Newton in the Principia 1687 in practice introduced the modern concept of integral, thus not formalized, First of all, Newton opened his text with the celebrate lemma 1. What does the lemma 1 says? It says that quantities and also ratios of quantities which in any finite time constantly tend to equality and which before the end of the time approach so close to one another that their difference is less than any given quantity d became ultimately equal. This is in practice the exact concept of limit. And now, how does Newton introduce the concept of integral? This might be very interesting and curious as well for the students. Newton introduced the concept of integral in his lemma 2. I read the lemma without reading the demonstration. If in any figure AACA comprehended by the straight lines AA and AA and the curve ACA any number of parallelograms, the parallelograms or rectangles are indicated by their diagonals. Any number of parallelograms AB, AC, CD are inscribed upon equal basis AB, BC, CD and have sides BB, CC, DD parallel to the side AA of the figure, and if the parallelograms A, K, BL, BL, W, CM, CM, DM are completed, if then the width of this parallelogram is diminished and their number increased indefinitely, is diminished and their number increased indefinitely, this is very modern, I say that the ultimate ratios, which the inscribed figure I don't read, the circumscribed figure I don't read, and the curvilinear figure I don't read, have to one another are ratios of equality. In practice, this is the modern concept of integral, which is explicitly introduced to calculate the areas of curvilinear regions. That is, which is explicitly introduced to generalize, thought in a partially different manner, what Archimedes did. Finally, this is my conclusion. After having shown that the problem of calculating the areas and the volumes of curvilinear figure has been addressed through infinitesimal technique, and after having seen that Newton introduced almost in modern terms the definite integral, now you can introduce the formal definition of integral and to develop the techniques of the integral calculus. But now the students will understand why such a formal definition is necessary and will appreciate the conceptual developments which have brought to our modern notion. I give another idea, final idea. Another possible argument can be added, an historical approach to the fundamental theorem of integral calculus, in which you can show that the problems of drawing tangent to a curve and to find its maxima and minima are analogous and are opposite to the problem of finding the area. Under the respect, the author we should use is Leibniz. Okay, Vincentas, my presentation is concluded.
Thanks, Paolo. You finished on time. It's unbelievable, Paolo, for you. Yeah. Please stop sharing your screen.
Excuse me. Okay. What do I have to do?
Just stop sharing.
You see still the slides?
Yeah.
Okay. Excuse me, Vincentas, but okay. Oh my God. Scare. What do I have to do to block condivision? Oh.
The same option as you started to share your screen. With this button, please press and stop sharing.
I have pressed. Yeah, but okay.
Okay, Paolo.
Okay.
You managed it. You managed it. It's fine. It's unbelievable, Paolo. Don't be lost in your life. Don't be lost. Okay, now, colleagues, I think a short discussion, and we see Paul. Hello, Paul. Malta is with us, but it was some small misunderstanding related with time zone, but no problem.
No, it's not a problem, of course.
Yeah, because
Thank you, Paolo.
Our motto, we want to keep everything under control. Everything should be as prescribed in time frame.
Yeah, but you've got a problem there, because I usually create problems and I prove that.
Okay, one first my question, Paolo.
Yes.
It's really interesting presentation, and for example, our team not right now, but we are working on one Erasmus Plus project, Bridge to Teach. It means bridging courses for science and mathematics, and our idea is, let's say, to help some students who are entering university, first-year students, because first they have, let's say, so different level of science knowledge and mathematics knowledge, obviously. So large, let's say, differences among students in their level. Secondly, let's say, it means for pre-service science and mathematics teaching. But generally, let's say mathematics, at least in Lithuania, but I think not only in Lithuania, because based we're discussing in our team in Austria, in Italy, because we have one partner from Palermo, University of Palermo in Italy, and the situation is more or less the same. Students do not like mathematics. Mathematics, it's so difficult, boring. Exactly. Etc. What do you suggest, or how to maybe connect for example, to integrate the history of mathematics, history of science in general for today's mathematics, or what do you think?
Yeah, of course, Vincentas. It's a difficult question, but in a sense, it is one of my fields of research. Of course, I think that history of mathematics can be useful not for history in itself, because of course, if one is interested in history of mathematics in itself, one studies history of mathematics. But history of mathematics can be useful in mathematics education because it allows you to start from single problems faced by great mathematicians. It can help the students to be in front of the same problems that these great mathematicians had, and hence it can be interesting from the student to see how general and abstract concepts in reality are born from for concrete purposes, and history of mathematics is of help under this respect. Of course, you have to select the problems which are interesting. I can also give an example for secondary school. A very easy example, for example, the way in which the second degrees equations are solved. It's easy, but it can be interesting to know the problems which were behind this question. Therefore, history of mathematics can help because you can use specific problems, and because through this method, the student can understand why afterwards it's necessary to introduce more general concepts, so that this concept do not look anymore absolutely abstract, annoying, boring, and so on. Mathematics in an historical perspective became an interesting activity, in my opinion, not only a set of technicalities.
Okay. Thanks, Paolo. Do we have some other questions or maybe some opinions? I do not see at least one comment. Or not. Lucas, okay, please ask.
If I can, thank you for an interesting lecture. I think it's interesting to see, because in physics, for instance, the way Newton and Kepler proved their sentences and they think is quite different from nowadays. It's much more bound to geometry, and it's not easy for me, for instance, to read Principia, because the kind of argument is different from the way we do. But my general question is, do you think it's reasonable to introduce the concept in mathematics education more or less in the order they were invented in history, so to follow the history, because it might follow some natural way how the things were invented or not? It is connected with the situation 40 years ago here in the Czech Republic, when we started mathematics education based on the set theory, which is of course very abstract. It's okay from the scientific point of view, but it was not very successful from the way of education.
Of course.
So my question is whether it is reasonable to try to follow more or less, not exactly per instance, but more or less with introducing the math concept, the history of math. Thank you for answer.
Yes, my answer is that it's reasonable to choose some examples from history of mathematics and to explain how the great mathematicians solved the problem which they have to deal with. Of course, it's too difficult and it needs too long time to follow an entire line of reasoning. I mean, why, if you have to introduce the concept of the integral, of course, it will be interesting to follow what Archimedes, what Kepler, what Cavalieri, what Leibniz, what Newton did. But it's impossible to do this, because otherwise it's a course of history of mathematics, not of mathematics education. Therefore, my tip is to focus on some specific problem faced by these great mathematicians, one or two problems, and to explain the connection with the mother concept, so that the mother concept is lived as a conceptual necessity, not as theoretical imposition. This is my answer.
Thanks, Paolo. We have in chat, Paolo, please check chat. We have one question from Angela James from South Africa.
But in Vincentas, excuse me, what do I have to do to look at the chart?
Paolo, in chat window, please open chat window. Small icon with...
Okay. Okay, Angela James, okay. Okay, Angela asks, how does history and the indigenous knowledges, for example, African, current held by communities link up? Well, Angela, I have to say that I am not able to answer this question. To be honest, I don't know. I am sorry, but I don't want to feign hypothesis because I am not able to answer, simply. I apologize.
Okay, very good scientific answer. Not political one, because
no,
somebody starting blah, 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 talking, answering. Yeah, okay. Maybe Angela can comment or a little bit explain her question.
Good morning, everybody, and thank you, Paolo, for a very interesting presentation. And I think when we're looking at the history of mathematics, any history for that matter, one has to look at the global histories and the role that various communities and cultural groups have actually played in that history. It's not history that's documented by one particular group or sector, because remember, the way in which the history was shared was in so many different ways. So I'm really looking at the inclusive nature of the knowledges that we actually work with. Thank you.
Thank you.
Okay, thanks, Angela. And I think we will keep it in mind with this issue and some other, and maybe we will continue after next presentation. I think we can start some minutes earlier, no problem. And Paul, are you ready?
Yes.
Okay. Thank you, Vincentas. See you later.
Thank you, Paolo.
Bye-bye.
Thank you. Thank you.
Thank you, Paul. Thank you, everyone. See you later.
So let me try to share my screen. Is it visible?
Not yet. Now it's okay.
Okay.
At least for me.
Okay. First of all, I would like to apologize for the mix-up this morning. The reason is that I forgot completely that Latvia is 1 hour before us. In fact, I was wondering at the late hour the conference was starting. The problem was obviously me, and I apologize again for mixing the whole organization up. Okay, my presentation will be focusing on the Sustainable Development Goals and how we can sort of ensure that science and technology become, or rather be, globally relevant. Throughout history, I think that science and technology has made it a point that the limiting factors, environmental factors that limit the spread and growth of the human population were controlled. I think one of the major contributions of science and technology were actually that of, for example, just to mention one example, control temperatures to allow humans to colonize various aspects of the planet. In fact, We managed to colonize practically everywhere, even in the sea, literally, through submariners and whatever, and also in space. We've just seen the China sending more astronauts into space to live there and the research there. So definitely this was one of the major contributions. Secondly, it also made food available for the human population, in the sense that it promoted industrial agriculture and rearing of livestock in a way that maximized food production throughout. Also, it increased, speaking about food, the fishing yield, in the sense that more fish are caught every day and practically entering the food chain, our food chain particularly. Obviously, with industrialization, urbanization was sure to follow, with all its pluses and also minuses, but definitely this also created a shift in populations, in the sense that several populations opted to go for the urbanized environment because it created more opportunities, particularly for jobs. Also, science and technology have, obviously, since urbanization was in, we needed an efficient transport and communication network that would sort of bring together various parts of our society. And we tend to use the cliche of a global village, when in fact we are a global village, in the sense that if there is someone who is filming and sending something from the other end of the world, we can actually see it happening in real time. And similarly, transport, although obviously the COVID pandemic has sort of curtailed some of the transport that we enjoyed. Also, science and technology improved sanitation and health services, in the sense that it's not just a battle of creating the right medicine to control certain diseases, but actually also getting into the genetic makeup of organisms, including humans, with the intention of actually eradicating from the roots certain diseases. Definitely, obviously this type of lifestyle has increased our thirst or hunger for more resources, and obviously technologies in this area, when it comes to resource extraction, has, mushroomed and exploded literally. So one would sort of conclude that we're living in a great world, practically heaven on earth. However, unfortunately, there were consequences that we had to pay for these sort of unlimited development, in the sense that our planet is a closed system. All right, there are some interactions between the planet and space and the planet, but overall it's a closed system. So the principle of carrying capacity is something that needed to be factored in this development. Unfortunately, it wasn't. And over here, I've just listed some, unfortunately some, because there are many others, consequences that this type of contribution from science and technology have actually led to. And it's not just issues concerning the environment, like depletion of resources, widespread pollution, etc., but also the impact on our economies, as well as, most importantly, on our human species itself. For example, although we've maximized the way we produce food, we're still facing famine. Definitely, there is inequality running at all levels of our society, not just when it comes to geographical regions, but also, for example, between genders and practically anything. Okay, we created a lot of inequalities. rather than having all this progress contributing to a better humanity, we practically created more and more problems for us to deal with. I think it's quite interesting what Yuval Noah Harari actually said in one of his books, that humans were always far better at inventing tools. However, we were not quite as wise when we were using them, in the sense that we actually focused on the problem and finding fixes to it without actually considering its impact, its consequences, what will happen next, what will be the true price that we'll have to pay for this particular tool, for this particular step forward. So it's quite interesting that there are, let's call them global tensions. For example, several initiatives have been going on to reduce global poverty. However, it is a reality that vulnerability, inequality, and exclusion of particular social groups and ethnic groups as well is on the increase. So on one side, we are sort of promoting the eradication of poverty and inequalities. On the other side, it's practically, the result is practically at a different level. Similarly, we're talking about an interconnected world. However, the level of individuality and the separation of individuals from society is increasing, and it is practically promoting insecurities, violence, and also conflict. Similarly, when it comes to economic growth, the aim of economic growth was that of making our world a better place to live in, to increase the quality of life. Unfortunately, it is being translated into environmental stress and a general lack of quality of life. On September 18, 2015, practically all member countries within the UN committed to identify a set of targets, goals, that since all of the team was in it, all of the team was committed towards ensuring the protection of our planet, which is practically our home, the end of poverty and inequalities, and that is practically conducive to ensuring prosperity by 2030. And in fact, this process was identified as the 5P process, where people, prosperity, peace, partnership, and planet. That's why it's called the 5 Ps. It's not peace, P-E-A-S, it's the P, the letter. It was sort of a process that was a follow-up from the MDGs, which were the Millennium Development Goals, which is basically there is a debate about the MDGs in the sense that the MDGs, the Millennium Development Goals, some would say that they were unsuccessful in the fact that they did not achieve all the targets that were set. But on the other hand, it is real that some of the targets were actually achieved, and we're speaking about a global effort here. It's not just tinkering with changes at the local level, but it's a global movement. And in fact, these signatory countries have agreed to a set of 17 goals, which are termed as the 17 Sustainable Development Goals, or in short SDGs, that, as I said earlier, they are there to measure progress in the coming year when it comes to ensuring a good quality of life on our planet. And in fact, these 17 goals have quite a range of foci, and I think that besides unifying the various countries under a common set of goals, these SDGs actually provided a clarification of what sustainable development actually means, how it can be translated, what's the currency that I can use in order to ensure that I'm practically doing things in the right direction. So I think that it was a major step forward. Obviously, when it comes to such agreements, one could adopt a purely pessimistic point of view that we won't succeed, that there are autocratic governments that will definitely, while signing to the treaty, will not comply, and all these challenges. But on the other hand, at least basing and looking at what has been achieved to date, one can be more positive and more optimistic that I think people are being fed up with the current state of affairs and want a change for the better. And I think one of the things that was important, and please don't get me wrong, like most of you, I felt quite bad during the pandemic lockdown, but let's reflect a little bit upon it. It's definitely an X-ray of our society, in the sense that it laid bare our vulnerabilities. We tended to think that the current makeup, the current organization of our societies, our economy, our definitions of progress were actually on the right track. But the pandemic has practically challenged this and showed that we need really to rethink what we define as progress, what we define as moving on, what we define as quality of life. I would also think that this was a minor dress rehearsal. I don't know whether you're familiar with the term. It's a dress rehearsal means if I'm doing, for example, a play in theater, we would have a couple of days before the actual event a dress rehearsal, sort of trying it out. It's like a piloting of a research instrument. And I think this was a dress rehearsal for something which is much bigger. Luckily for the pandemic, there is a vaccine. Unfortunately, for the larger calamities, like, for example, climate change, there is no simple solution because, and in fact, that is why it's referred to as a wicked problem. It doesn't have a switch on and switch off button. It has so much ramifications in any aspect of our being that, that there's no easy solution. However, there were some positive aspects to the whole problem of the pandemic. And one of the facts was that nature proved that if given the opportunity, it can heal itself. It can right the wrongs that we managed to create over time. And we've seen, for example, the return of fauna in places that were not even visible. The quality of the air has improved. Okay, the networking between persons has improved. And we've seen gestures of solidarity and cooperation that we haven't seen for such a long time. Again, one can always see at the part of the glass that is half empty. But again, I think I'm speaking to an audience which is positive and optimistic. I think it was also, as I said earlier, a wake-up call. An invitation to change the way we do things. The current way is not delivering the results that we really want. We need a course of action. Going back to normal is not enough. Business as usual will not get us anywhere. And a very positive experience was that people have adopted and found new solutions to the limitations of the pandemic. And particularly, and this is quite laudable, these initiatives have sprung from youth and women. And the reason why I'm pointing this out is because both these groups have been identified since 1992 as the change agents to promote sustainable development. And obviously, there are two groups that suffer a lot of exclusion, that are not treated the way they should. I would like to share with you a very brief video which explains the projection when it comes to education within UNESCO. I hope that the sound is coming through. Is it coming through?
What kinds of futures do we want to shape? Accelerated climate change, artificial intelligence and biotechnology, increasing exclusion and fragmentation. Our world is becoming more complex and uncertain with many disruptive challenges. Knowledge and learning are humanity's greatest renewable resources for responding to challenges and inventing alternatives. Yet, education doesn't only respond to a changing world. Education transforms the world. But to create the futures we want, we must rethink education. UNESCO has launched a global initiative to reimagine how knowledge and learning can shape the future of humanity and the planet. We are looking at 2050 and beyond, and we want to partner with you to discuss, debate, and re-envision the ways education enables us to become what we want to become. For ourselves, for each other. Thinking together so we can act together. Join the conversation and let's make the futures we want.
This particular initiative, referred to as Futures of Education, Learning to Become, is practically an evolution of a process started in UNESCO quite some time ago, where the journey within education has practically shown the need to focus more and more on the learner within a sort of ecosystem that is around the person. It's a way, as this poster of the initiative highlights, to reimagine how knowledge and learning can shape the future of humanity and the planet. It is not just a myopic view of education, but it's a much wider one. In fact, this horizon of 2050, which practically is being targeted by a lot of initiatives, aims to address three major foci. One of them is that education becomes a tool not to sort of prepare individuals for the future, but to actually respond to everything that is making our life on this planet less than our expectations. This means that the way we teach and the way we learn needs to be reframed, needs to be readdressed, needs to be retaught in a way to focus on enabling individuals rather than transmitting knowledge. And in fact, this is the next pillar. How we manage data, how we manage knowledge, and obviously how we manage education. There was a time, like we are all aware of, because I assume that we've passed the teenage years. Excuse me if there are any within that age, but we remember a type of education where rote learning was a survival skill. Why? Because the information out there, knowledge out there, was not easily available. For example, books were practically out of reach of a lot of the people that wanted to make their future better through education. So there were libraries that we used to go there, learn stuff by heart, in the attempt that eventually, if I need that knowledge somewhere, I can actually access it from the corridors of my mind, sort of, and reproduce it in examinations or wherever. Nowadays, knowledge is easily available at the touch of a button. I can challenge anyone to come up with a question that I don't have any answer to it, but I will actually give you an answer if you give me some time to search on the internet. You know what I mean? So maybe I am making the issue too simplistic, but definitely this new source of knowledge and the easy accessibility of it requires a new set of skills that need to be addressed, like, for example, ensuring that the knowledge that I am basing my ideas on, my knowledge on, is actually knowledge which is correct, that it is precise, that there is no hidden agenda behind it. So these are sort of new skills that need to be explored when it comes to dealing with data, knowledge, and education. In 2005 saw the launch of the UN Decade of Education for Sustainable Development. And in fact, there was a global action program launched aimed at promoting an education that prepares individuals, irrespective of their various characteristics, to a world where sustainable development becomes the most common way of life. And it proposed 5 priority areas, which were the directions for this particular period after the decade. The first priority area was that of promoting policies that would integrate ESD, Education for Sustainable Development, within structures. Okay, having a policy which determines how you go about it, not just leaving it to hunches and likes or dislikes. Obviously, as we pointed earlier on, we need to transform also, and this is another priority area, the environments themselves. It doesn't make sense for an educator to talk about, for example, the reduction of waste, when practically the school, the university in which this educator functions is practically oblivious of the amount of waste it produces. Okay, so there needs to be not just talk, but as the expression goes, that we walk the talk, that the way we make decisions put certain priorities, and these are sustainability, and this is sustainability, before other concerns. Because obviously we believe that living a sustainable mode of life will improve our lifestyles. Also, we need to invest more, and this is another priority area, in educators and trainers, in the sense that there are challenges, which I will be pointing out later on, that obviously educators and trainers need to be brought up to scratch with. Again, empowering and mobilizing youth. We've seen various examples of this throughout our life. The two main movements that come to mind is obviously Malala and her drive to promote accessibility of education, particularly to girls, and also lately Greta Thunberg and her movement to make us aware of the imminent dangers that we're facing because of climate change, and also accelerating solutions at the local level within the communities. because this is a very important, it might not seem like it, but it is a very important step in the right direction when it comes to UN initiatives. There was a time when the UN thought that if there is a global agreement, there will be its benefits will trickle down towards the individuals in the various countries. This has actually proved not to work. It's the other way around that needs to be promoted, in the sense that obviously there will be directions coming from above, but the main emphasis, rather than to transmit those ideas, is to actually empower the individuals to make steps in the right direction. And this would lead to, besides individuals, lead to communities, localities, nations, regions, and eventually we'll have a global alliance. This was something that was in fact highlighted way back in 1987 by the document Caring for the Earth by IUCN, WWF, and UNEP. Now, after let me go a little back. So this was the plan till 2019. What's the plan beyond that? And obviously we are already beyond that. The idea is to actually, I'm going to share with you, focus more on efforts of empowering people. In fact, the new framework that is being proposed actually relates what has been done in the Global Action Programme to the SDGs. The strategic objectives, if you're noticing, is that, as I said just a couple of minutes, focusing on the individual transformations that will eventually lead to changes in society, and obviously give technology a different perspective. We're defining progress in the terms of well-being when it comes to individuals and societies. The priority areas are the same 5 that I just highlighted, and the target groups are policymakers, definitely, institutional leaders, learners, parents, educators, and youths and communities. So practically it's everyone, but particularly these particular roles which are considered as being gates, keepers to progress. Okay. When we're speaking about ESD, and this is very important because towards the end we'll be matching this with what we considered as appropriate science education. It is a process-oriented initiative where we value the process over the product. It's not, for example, knowing about science, but actually doing science the way we think. It doesn't really matter whether, for example, I know all the theorems and all the relationships within any field of science, if I actually don't put those into practice, if I don't use them to interpret my surroundings. So doing something, the process, is more valued over the product, without obviously disregarding the importance of focusing on the product, obviously, but the most, the emphasis is on the process itself. It is holistic, meaning that it values interdisciplinarity over monodisciplinarity, because unfortunately, let's highlight the fact, and if we're earlier on, PAOLO has already pointed out the history of mathematics and how it evolved on certain concepts. Notice that one of the interesting aspects when it comes to learning is that these monodisciplinary silos have been created by humans. They are a human construct. Why? Because reality out there is interdisciplinary. And okay, one might argue that you need to, in order to analyze, you have to break an issue up into its components and explore its components in more detail. Okay, but at the end, it is very important to relate every aspect again together to give a holistic perspective of what you were originally exploring. It is participatory in the sense that students are not seen as just passive recipients, but they are actually involved in all stages of the process. This is very much related to what I mentioned earlier when it comes to process orientation. It is transformative in the sense that it empowers learners to become agents of change. And it empowers learners to become agents of change today, not for tomorrow. And it's very important to conceptualize this, because who, let's be honest with ourselves, who of us is, as long as there's no one called Nostradamus or something like that within this group, but who can actually predict what will happen in 10, 20, 5 years' time? Who actually anticipated what will happen when it comes to COVID? So what is needed is practically to prepare learners for change. There is no real sort of defined future that we can prepare students for. It's an ever-changing future that they are facing. Also, as obviously is one can detect, it is learner-centered in the sense that it values the learner over the subject matter. So even when it comes to selecting knowledge, selecting content, what is of paramount importance is of what is relevant to the learner herself or himself, in the sense that at times we tend to start, when it comes to curriculum development, we tend to start off, okay, so my subject is subject X. Definitely we have to input this concept because it's very important, and this concept, and this concept, and this concept. And then we'll, you know, make sure that there is some application so that students can relate it to real life. Yes, but one needs to ask, whose real life? And when is this life actually experienced by these students? It is also inclusive in the sense that we have different students having different abilities. And if we are speaking of education, we're speaking of promoting initiatives that provide an opportunity for all these students to reach their full potential. It is problem-oriented, basically giving opportunities for students to address a situation, think critically about it, explore different ways of approaching it, thinking about the consequences that decisions will incur, and actually responding to it. It is community-based in the sense that it promotes and it facilitates interaction with the community. It's not in line with the old mentality that schools and the universities are silos, where practically they are detached from the realities, and that is important, otherwise they can't give an unbiased view of society. And it is action-oriented, as I pointed out, and the best way of showing this is that it adopts a whole institutional approach, as I mentioned earlier, in all the decisions being taken. One of the gurus of education for sustainable development, the late John Smythe, used to say that good environmental education or good education for sustainable development is essentially good education. So we're not reinventing the wheel here. And unfortunately, when it comes to looking at what ESD promotes and what is traditionally accepted in most of our educational institutions, there is a clear conflict in the way we treat learners, in the way we organize our curricula, in the ways we function as an institution, and the way we connect with the outside world. there is a direct conflict. And this leads us to the dilemmas that we're facing with science education, in the sense that what type of science are we promoting? What type of technology we are looking at? Has science and technology become a means to an end, that is a tool, or has it become an end in itself? That is, it is important to learn about science and technology, and then eventually you will be making use of it in the future when you are where you become an engineer or a scientist or a researcher or a doctor or whatever. What is the type of science that we are promoting? Practically, when I'm speaking about relevant science education, relevant to whom? Relevant to the curriculum developers or to the learner? I'm assuming here that we're speaking about the learner. So it has to adapt to the needs of the learner and society. Definitely, it has to develop a holistic perspective. Why? Because the experiences out there are holistic. And if we need to develop learners who are functional, we need to get examples and help them reflect on examples that are the reality in their communities and in their experiences. I remember my childhood days where, for example, obviously for those who are not aware of my country's past, we were a British colony. And I remember, and we're spot on in the middle of the Mediterranean, so definitely our climate is very different from that of the British Isles. And I remember actually our science lessons. For example, one of the examples that comes to mind is the lifestyle of the frog, which was the example of an amphibian. In parentheses, in Malta, we have just one amphibian because of our dry climate. But well, the book actually said that the frog hibernates during the winter and comes out in summer. Yes, the British frog, the Maltese frog, if he does that, he's out for a very big surprise, because in summer we don't have any water running around, you know, that is available during winter. So this is just one simple example, but practically, even for example, when it comes to fieldwork, most of our fieldwork in Malta was carried out in the woodland, which we have just a simple single example of. Okay, why? Because most of the educational material that we were used to at that time focused on woodland. There was no field work in Malta, a small island in the Mediterranean, about, for example, the marine environment or the shore environment. So definitely it has to come up from the experiences. As I highlighted earlier, it promotes interdisciplinarity, blurring subject borders, and I think this is quite apparent even when it comes to interdisciplinary research groups in science. There is no particular answer within any, solely from any particular discipline. Like, for example, if we're dealing with, for example, genetic engineering, how on earth can you disregard chemistry, for example, or even physics to that effect? It adopts diverse and innovative teaching and learning experiences. Why? Because there are different learners. And these different learners also require different ways of evaluating proficiency in science. It's not just learning by heart. And also it depends on flexible structures that can obviously adapt to different learner needs and realities. So the infrastructure needs to respect this. Unfortunately, in most of our educational institutions, and allow me to say this, university are the prime example, the infrastructure is victim to turf wars and power struggles between different disciplines. Even when it comes to programs, they are usually structured around the subject's needs or even the staff needs, not the learner's needs. Science curricula tend to be too content-oriented and based on recall. And this means that time constraints become one of the realities when it comes to curriculum, because it's overloaded. And curriculum developers obviously acknowledge reality, but are afraid to engage with it. Why? Because there might be issues, ethical issues involved, because there might be political connotations to what we're doing, because it will definitely impact the economy negatively, because we're highlighting certain flaws in the current way things are going. Yes, but if we're doing that, what sort of preparation are we doing? Are we giving to our children? Okay, so we need to engage in this. And obviously, unfortunately, heavy reliance on certification and examinations is determining the type of pedagogy that is predominant in our education institutions. Subject choice, for example, is more determined to a great extent by job prospects. The main target of the curricula, therefore, will be students who intend to pursue a career in science, rather than ensuring, I'm not saying that one or the other, but obviously, while preparing students for a career in science, we also need to consider students who won't be taking a career in science, who would need science as a language to interpret the realities that they find around them, what we call science literacy. The need for science education, yes, it has increased. Why? Because the input of science and technology, as I highlighted earlier, has increased. And this is practically seen by the proliferation. It's practically, it's like bacteria reproducing asexually in the right conditions. There are several courses where applied sciences is provided. So this shows that there is a proliferation of expectations when it comes to science. Support needed, first of all, is the political will. Now, with political, I don't mean the capital P politics, but also the small p within the institutions themselves, the curriculum developers, the way schools are organized. We need a policy framework that integrates ESD into the curriculum. If we believe that what ESD offers is important, is an entitlement in the education of our students, it has to be incorporated into curriculum. It cannot be considered as an extra curricular activity, or that everyone will be doing it. If it's not mandatory, no one will be doing it. Obviously, as highlighted in several aspects of this presentation, we need adequate teacher education programs, but also we need to continue the support for teachers in class. Not just sort of prepare them and unleash them in the outdoors, sort of. Yes, but we need to help them realize that there are certain issues that need to be addressed because they develop while teachers are actually full-time teachers now. One of the ways of ensuring relevance is to actually involve teachers who are, and educators who are involved in teaching. Because why? Because they face the music. So obviously they have inputs and concerns that people who are just desk bound are not aware of. Engagement with the community. I think this is very important, particularly the NGOs. Why? Because when engaging with the community, it provides an opportunity to sort of move away from the rigid structures of formal educational settings and going more into more enabling methodologies that bypass bureaucratic hurdles of formal institutions. And I would like to finish off by giving you two examples who have made science education more accessible to students in Malta. One of them is Eco Schools. It is UNESCO has identified Eco Schools as the largest network of students and teachers involved in ESD. We're speaking about 19.6 million students spread in about 69 or 70 countries. The process through which this program is conducted, it's a methodology basically, where you organize a school committee, which is practically made up of quite a lot of students. Let me rephrase that. the overall number, there's more students than adults composing the committee. They run an environmental review of the school, identifying issues that need to be addressed. They come up with an action plan, identifying what actions they need to do, how to ensure that they are being done in the right way, who will be doing it, and by when it will be achieved. Obviously, once the action plan is implemented, it is monitored and evaluated. The targets of the action plan are integrated within the curriculum, so they have currency within the school. Most importantly, this is not just limited to the school committee, but it has to be enlarged to include the whole school and even beyond, and that is what informing and involving is all about. And there has been quite interesting spin-offs within the community, and eventually the identifying of an eco code, which would be the sort of the vision statement, the mission statement of the committee. The second program is also quite a large program sponsored mainly by NASA. It is an international program. Again, GLOBE stands for Global Learning and Observations to Benefit the Environment. If I don't have it written up, I forgot I forget the acronym. But basically, it provides protocols that are followed by students ranging from preschool to postdoc. And these obviously create an opportunity for students to not just explore and understand environmental parameters around the globe, but to actually engage in doing science to offer solutions to current issues that they are facing within the community. Just to give you an example, two initiatives that were carried out by students. Luckily, because of COVID, most of our beaches were not being used, and this meant that about on different locations, we had 5 sea turtles coming up on the beach and laying the eggs. This prompted students, obviously the area was cordoned off, protected. However, students requested to be part of the teams that were set up to guard the nests from predators like rats and ghost crabs. But while sitting there, they wanted to explore more about the nature of hatching. And in fact, they found out that temperature, in the sense that eggs being laid at the very bottom and that eggs being laid up at the very top layers, have different exposures to temperatures, and this will determine the sex of the offsprings. And they actually conducted experiments and data collections around the nest, and they actually contribute. And these were students coming from a secondary school, which would be 11 to 13-year-olds, actually producing results that were eventually used by a Puerto Rican university, which were looking at the effect of temperature on gender in turtles. Another similar event was carried out on microplastics by students, and the effect of microplastics on pH and temperature of seawater. Again, their results were, again, we're speaking about secondary school students, they were used, and they actually were discussions with university research individuals. So, thank you. Basically, the last slide is that when we're looking at what we call the 21st century skills, definitely science education can prepare students for the 21st century as long as it becomes more flexible and, more importantly, sensitive to the needs of the learners and the community that it is supposed to respect and promote. Thank you.
Thanks, Paul. It's really nice presentation. It's quite good information, etc. We have one question. If you see in in conversation window.
Let me see, sorry. By Rita.
Right.
To what extent do you think the education could increase? I can't see the whole question. I don't know why. Wait, okay. Oops. It's not giving me the whole text. Let me try.
I can read.
Yes, please, if you can.
To what extent do you think ESD education could increase people's knowledge of coronavirus and vaccines in the current COVID pandemic situation? What methods could be used?
Well, I think basically it all depends on the realities of the country itself, of the community itself. Let me give you an example from our particular experience. Obviously, when it comes to the COVID situation, most of our schools were in lockdown, and particularly during the first wave, the lockdown was quite severe in the sense that there was no contact in school except through online media. However, this helped to focus more on the relation between what's happening in schools and what's happening in homes. Because why? Parents were involved in the teaching as well, because obviously most of the learning was being done at home, what we call home teaching. As regards when it came to the COVID, there were students who were looking at, and this was, remember, this was before the vaccine was actually available. They were looking at the impacts of what was happening basically to our society, in the sense that most of the shops were closed, and certain teachers actually used that in a way to promote the discussion on, for example, whether the economic model in Malta was being conducive to promote advances in our society. Eventually, there was some discussion being done on vaccines, and I can remember 3 particular cases where they started looking at different ways of and discussing the different type of vaccine being produced here, because obviously it did not involve the whole virus as previous vaccines used to. So there was this sort of interest, and it sparked off particular interests also in social interactions, particularly when it came to other subjects there. Like, for example, I have a particular example in mind of students actually involved in creating rap songs and integrating language exercises with that. I don't know whether that answers your question, Rita.
Thanks, Paul. And we have 2 more questions. Do you see in conversation?
Yeah. I wish I would have the answer for that. I've been trying to negotiate, and in fact, just after this particular meeting, I have to rush to the ministry to actually continue on helping the policy makers to. But
at least shortly, when will our leader and policy maker understand the significance of? Yeah,
that is what I mean, in the sense that policymakers and leaders need concrete examples. So what I would suggest, this is how we carried it out. I'm not saying that is the only way it's being done, but basically what we did was we started using Globe and particularly eco schools, having good examples by kids, showing how they integrate ESD within their curriculum, and at that time it was an extracurricular activity. And in fact, and I can vouch for this because I was present for the discussion, when the government was coordinating the development of the national curriculum framework for Malta, there was someone who said, you've seen these UNESCO things, they are promoting ESD, how about including it in the curriculum? And another person said, what is ESD? And this person said, just look at what happens in eco schools. That is ESD. And ESD is now part of our policy. So my suggestion is politicians need to see results, need to see good practices. So I personally advocate going back to the grassroots, to the teachers, working with teachers, come up with good examples and promote that with policymakers. Policymakers are easy prey to come and, open up, things and taking photographic stuff with kids. So you might address that way. I don't know.
Okay.
Whether...
And in your Malta experiences, how many schools have been involved?
Okay. When it comes to eco schools, we're speaking about 84% of the total student population, ranging from kinder to post-secondary. And we are practically moving towards a situation where we also are opening up also at the university. So we're speaking about quite a large chunk of the student population. It started off by 6 schools way back in 2010-2, and it gradually, using, as I said earlier, examples of good practice from other schools, it actually mushroomed into this major force. I would say it is a major force when it comes to ESD implementation. When it comes to Globe, it's still catching up. Why? Because it was introduced 3-4 years ago. So, but it's catching up again like wildfire because, and that is the strategy that I suggested, you share experiences, good experiences, so that people can say, he's facing the same or she's facing the same problems that I do. Why is she successful in what she's doing? And that's how they learn from each other.
Okay, thanks. Do we have some other questions to Paul? We have 5 minutes. 5 minutes to the end of this session. If possible, Paul, my question, short question. It was mentioned, obviously, this is like integral, let's say, thing, but what about value education, let's say bioethics, etc.? Because value education, I think it's somehow...
Yeah. My question is, how can you teach science in a relevant way if you don't go into ethics and values? We're running a joke when we say that we have to be objective, steer away from these issues. No, these issues are part and parcel of how things are carried out there. It's personally, I'm not saying that there is a particular thing, a particular value that has to be indoctrinated. I'm not saying that, obviously, because indoctrination and education don't fit in the same box. But we're speaking about helping people deal in a learning environment, in a safe learning environment, because it's still the class, how to deal with ethical issues. Because why? Because when they're out there, they have to face these. It's not something that you just open a book and read about it. You have to, because when dealing with values, it's an issue of exploring your personal set of values and also relating it to new values and see which one makes sense or not. So this sort of thing needs to be supported and promoted by education. And I think science is in the right position to promote this type of education. I know that sounds quite different from what traditionally was promoted through science education, but experience has shown that if we don't address issues like values, we cannot ever come up with an educational program that promotes action. Otherwise, we'll still be theoretical. I don't know whether that answers your question, Vincentas.
Thanks,
I'm just posting my email just in case people would like to follow more discussions later. I'm up to. What about culturally specific knowledge and practices? Again, Angela, I perfectly agree with you. And unfortunately, and this I highlighted this when I was invited to Namibia to give a keynote for ESD there. I must admit, and with a heavy heart, that I was completely unaware of not just the indigenous knowledge, but also the research being done in ESD in the countries, because it wasn't just Namibia, but there are several African countries. And my reaction was, please make this knowledge known, these experiences known, because we are sort of, I hate using these words, but unfortunately they are real. We tend to promote, even when it comes to knowledge, colonization, and coming from a country who has been a colony since the Carthaginians, okay, way back in Roman times, okay, up to the 60s. I know what that means, in the sense that you promote certain, within inverted commas, valid knowledge, while the real valid knowledge is not given enough attention. So personally, again, go back to the roots, the grassroots, promote those, and obviously value those, because why? Because they are direct relevance to the community, and particularly to the learner himself or herself. I don't know whether that answers your question.
Thanks, Paul. If somebody wants to comment, please. No hands, no more questions. I think it was really a rich presentation, and we need to summarize somehow different thoughts and ideas, and it's really good. And dear colleagues, our first plenary meeting successfully ended. Hope without serious problems. It was everything okay, and I checked on Facebook. Also, our translation is going on. It seems good. And now we have half an hour as coffee break or tea break or wine break. It's up to you. It depends on the time zone, maybe lunch, maybe whatever. And I hope we will meet again in half an hour with session 1. And just to remind you that for every in majority of cases, for every presentation, we allocated half an hour. It means that I would suggest 20 minutes for presentation and 10 minutes for questions and discussion. And only for some, at the end, I think we have 2 presentations or 3 presentations for 15 minutes, because people registered after deadline, and then we wanted to keep them into program, and we allocated a shorter time, but I think it's not a problem. And our session, afternoon session, will be also successful, I hope so. And now it's coffee break. Yeah. Do we have some? If you have.
Thank you, Vincentas.
Yeah, I see some more questions. Put the program up, please. Program is available at our website at BalticSTE2021. Everything is available on Symposium website, including greetings, program, poster, etc. And we will keep this website updated as soon as possible. For the afternoon, right? This is the same link for afternoon session, the same link, and for tomorrow, just again to inform in advance. In order not to be lost, for tomorrow it will be another link you will receive at the end of this day. You will receive next link and also invitation via Teams plus link for tomorrow.